Okay, so I'm going to show you how to do your calculations for the egg drop. So I've already taken my measurement for the table and I converted it to meters. I also took my measurement for the porch and I converted that to meters. I recorded my time for the table drop and I recorded my time for the porch drop and I've recorded my time for the stadium drop. So we weren't able to measure the stadium because it's so high, but luckily using equations, we can actually calculate what that height is. Okay, so my initial velocity, remember at the top of the drop is 0. So I'm going to put that here in these fields because it's 0 for each one. I'm going to calculate my final velocities. My acceleration of gravity is 9.8 meters per second squared, and that's for each drop. That does not change. And then I'm going to record, is it a successful drop or not? So if my egg cracked or broke, that would be a no. But if it went through the drop and was fine, then I choose yes. Okay. I've also taken the mass of my container. I've taken the longest dimension, which was 30 centimeters. I converted that here to meters, and then my distance from the target for the stadium. So your numbers are going to be slightly different, but the calculations, this will give you an example of how to calculate things. Okay, so down here in the diagram, you're going to insert the picture that you've taken for the stadium drop. We're going to calculate the height of the stadium. That's our unknown. And so we're given VI, which is 0. Our G is 9.8. And our time for the stadium is 1.29 seconds. Okay? My unknown is the height of the stadium. Here's the equation that I'm going to use. The distance is equal to the initial velocity times the time plus 0.5 times acceleration of gravity times the time squared. Okay, so I'm going to substitute in the numbers from my given into this equation here. So VI is 0. My T is 1.29 plus 0.5 times G, which is 9.8, times T squared, which T is 1.29. And then I'm going to solve this. So 0 times anything is going to go to 0. So I'm just left with this calculation here, 0.5 times 9.8 times 1.29 squared. So it's just the 1.29 that is squared, not the other numbers. When I calculate that, I'm going to get 8.15 meters. Okay, so that's the height of the stadium, 8.15 meters. Okay.